Hey everyone, today we are going to solve the Daily LeetCode challenge of 23rd March 2024, and the problem statement is reorder list. So let us first understand the problem statement. So according to the problem statement, we have been given a linked list. So let's see how do we represent a linked list. Suppose this is the 0th node. So we have the 0th node. After that, we have the first node, then the second node, third node, and so on, followed by the n minus 1 node and the nth node. If we have a total of n nodes present in our linked list. And what do we want to achieve? We want to reorder this list. Now, how do we want to reorder? We want the first element, that is, we want the 0th node. After that, we want the nth node. So we will have ln over here. After that, we want the first node. So we will have L1 over here. After that, we want the n minus 1th node, n minus 1th node, and so on. Okay, so it might be a little difficult to understand it like this. Let's see it with the help of the given example. So how do we want to reorder this? We want the first node, so we will have 1 over here. After that, we want the last node, so we will have 9 over here. Then we want the second node, so we will have 2 over here. Then we want the second last node, so we will have 8 over here. Then we want 3, so we will have 3 over here. Then we want 7, so we will have 7 over here. Then we want 4, we will have 4 over here. We want this 6, we will have 6 over here. We want this 5. We have 5 over here. So now you can see that we have processed all the nodes of the given linked list. So what does it mean? It means that we have successfully reordered this list. And this is the resultant list. Now you may have noticed that while selecting this 1, 2, 3, 4, how did we move? We moved forward, correct? And while selecting this 9, 8, 7, 6, how did we move? We moved in the backward direction, right? Like we had this 9 first. After that, we had this 8, then we had this 7. So we moved in the backward direction. So let's see how we can reorder it. So what we will do is, we will firstly find the middle of the linked list. Okay, find mid of the linked list. So let's see that if this is the linked list given to us, then what would be the middle? Then the middle node would be this 5. Because if we choose this 5 as the middle node, then it is equally dividing this left half and the right half. So our mid node is 5. Now, once we have found out the mid node, after that, what are we going to do? We are going to reverse linked list from mid to end. Okay. So let's see what we will get if we will reverse this part, right? Because we want to reverse from mid to end. So what we will get? We will get 1, 2, 3, 4. And we will set the next of this 4 as null, correct? So we have only up to 4. And what we have done is we have reversed this part starting from mid to end. So what we will have? We'll have 9, 8, 7, 6, 5, correct? Now, once we have reversed this linked list, and after that, what we have to do? We have to follow the third step. And what is the third step? The third step is reorder the list. Okay. Now, how are we going to reorder it? So this is the resultant linked list. So we can see that after this 1, what do we have? We have this 9. Okay. So what we want to do is we want to set the next of this 1 as this 9. Okay. Now, if we will set the next of this 1 as 9, then what will happen? This link will break. Correct. Because we have created a link from 1 to 9. So obviously this link will break. Correct. So if this link will break, then what will happen? This entire data will be lost. So we don't want to lose this data and we want to preserve it. So how are we going to preserve it? We'll preserve it by storing it in any other variable. So let's say the variable is next. So I am representing it as nxt, next. Okay. And let's say this is current. So I'm representing current as cur. Okay. Now we also need to store this 9 in some sort of variable. So let's call that variable as reverse head. So I'm representing that reverse head as RH as of now. Okay. Now we can see that we have successfully made a link from this 1 to 9. Correct? We have a link from this 1 to 9. Now after that, what we want? We want a link from this 9 to 2. So what do we want to do? We want to set the next of this 9 as 2. Okay. So if I set the next of this 9 to 2, then what will happen? This link will break, and if this link will break, then this entire data will be lost, but we don't want to lose that data. So what we will do? We will store this in some other variable. Let's call that variable as reverse head next. Okay, reverse head next, because this was reverse head, so this is the next of the reverse head, so I'm naming it as reverse head next. Okay, so what we did, we created a link from this 9 to 2. Now what we have achieved? We have achieved till here. Okay, we have 1, after that we have 9, after that we have 2. Fine. So firstly, what we did, if 1 was at current, so what we did, we set current next. We set currents next as what? We set the next of current as this reverse head. Correct. So what did we set? We set this current head as reverse next. And after that, what we did? We set the reverse heads next as next. Correct. because 9 was in reverse head and 2 was in next. And what did we did? We created a link from this 9 to 2. So what we did, we set the next of this reverse head. We set the next of this reverse head as 2. And where is 2? 2 is in this next pointer, correct? Okay. Now what we want to set the next of this 2 as 8, right? We can see over here that we have 8 in the next of 2. So what we want to do, we want to create a link from this 2 to 8. Now, if I create a link from this 2 to 8, then what will happen? Then this link will break. And if this link will break, then this data would be lost. So we don't want to lose this data, right? So what we will do is, and how we can set the next of this 2 as this 8. So before doing that, we have to move all these pointer. So our current was at 1. Now what we will do, we will move current by 2 steps. So if I move current by 2 steps, then what will happen? Current will come here. It's the 1 step. And current will come over here, which would be the 2 steps. So current is now pointing at 2. Okay. So current would be pointing at 2. And we want to store the next of current as well. So next pointer will move at the next of this current. So next will point at 3. Okay. Similarly, this reverse head will also move. So what will reverse head be? Reverse head will now point at the reverse head next. So this would be our reverse head. And what would be reverse head next? Reverse head next would be the next of reverse head. So this would be the reverse head next. Okay. Let me remove all these unwanted lines. Let me also remove these rings because it has been broken, correct? Fine. So what we did, since our current is at 2, so what we did, we set the next of this current as the reverse head. What we did, we set current next as reverse head. So current was here, so current next would be this reverse head. Okay. So this link will break. Okay. So let me remove this link. This link will break. Okay. Now what do we want? Now after that, we want to set the reverse head next as next. So where is our reverse head? Reverse head is the 8. Now what we want to do, we want to set the next of reverse head as this next. So it means we will have a link from this 8 to 3 and this link will break. Now after that, what we have to do? After that, we can see that we have successfully created a link from 8 to 3. So what we have achieved till here, correct? Now what we will do, we will move this current pointer again by 2 steps. So current is at 2. If it will move at 2 steps, then where it will reach? If it will move by 1 step, it will reach at this 8. And if it will move by 2 steps, it will reach to this 3. So this is our current now. This is our current. Okay. And if this is our current, then this 4 would be the next. Correct. And we also have to move this reverse head. So what would be our reverse head? Reverse head would be reverse head next. And what would be reverse head next? Reverse head next would be equal to the next of the reverse head. So this is it. Okay. So what we did, we moved current by 2 steps. That is, we set current as currents next. Okay. But before this, we have to make a check. What check do we have to make? Let us assume that what if this current next is null? If this current next is null and we are trying to access the next of null, then it will give us a runtime error. So before setting this current, what we have to check? We have to check that if this current next exists, then only change this current pointer. Correct. So what we did, we set this next pointer as the next of current, correct? Currents next. So we can see over here that here we had this current, right? And what was this next? This next was nothing but the currents next. So we set this next as the next of current, correct? But before this, we also have to make a check. And what check do we have to make? Let us assume that what if our current is null? If our current is null and we are trying to set next as the next of null, then it will again give us a runtime error. So before this, we have to check that if our current exists, that is if our current is not equals to null, in that case only set this next pointer, correct? And what we did, we can see that clearly what we set as reverse head, we set reverse head as the reverse head next. So what we did, we set reverse head as reverse head next. And what we set as next, we set the reverse head next as the next of reverse head. So if this is our reverse head, so what we have done, we have set reverse head next as the next of reverse head. And when are we going to do this? Before doing this, we have to also make a check that our reverse head should not be null. So we have to check that if our reverse head exists, in that case only update this reverse head next, correct? So let's continue the dry run. Okay, so our current was at 3. Okay, now what do we want? We want the next of 3 as 7, right? We want the next of 3 as 7. So what we will do? We will set the next of current as reverse head, correct? Because in which we have 7. We have 7 in this reverse head, right? So if we will set the next of this current as reverse head, what will happen? This link will break, correct? And after that, what we want? We want to set the next of this 7 as 4, right? We can see over here we have 4 in the next of 7. So what we will do? We will set the reverse head next. Why? Because 7 is present in reverse head, right? We'll set the next of reverse head as this next variable, correct? Because in this next variable we have 4, right? So what will happen? This link will break. Now once we have done this, what we have to do? We have to move current by 2 steps. So our current was at 3. If it will move by 2 steps, so if it moves by 1 step, it will reach at 7, and if it will move one more step, it will reach at 4. So our current is now at 4. And what is next? Next is the next of current. So our next would be now null. So we have null in next, correct? And where will our reverse head go? Our reverse head would be reverse head next, correct? We can see over here that what is reverse head? Reverse head is reverse head next. So we will have reverse head over here, and what would be reverse head next? It will move by 1 step as well. So we will have reverse head next over here, correct? Now what we want to set 6 in the next of 4, right? We can see over here, we want to set 6 in the next of 4. So what we will do, we will set currents next as reverse head. So what will happen? We will be able to create a link over here, okay? And after that, what we want to set? After that, what we were doing? After that, we were setting the reverse head next as next. So where is our reverse head? Our reverse head is at 6. And if we set this 6 as next, then what will happen? This 6 will point at null, correct? But do we want this? We don't want this, right? We don't want the next of this 6 to be null, correct? We want 5 in the next of this 6, because we can see over here that what did we had here? Here we had this 5 in the next of 6, right? So we will check that whenever our next becomes null, in that case, we don't have to do any processing, correct? So before setting this one, that is before setting reverse head next as next, what we will do, we will check that if our next becomes null, right? If our next becomes null, in that case, we don't have to set this reverse head next as null, correct? So what we will do, we will simply say that if our next is null, that is if next does not exist, what we'll do, we'll simply return. Okay, that is we don't want any further processing, and we have got our answer, correct? Now I hope it's clear to you all that how are we going to reorder the list. Now let's understand these 3 individual steps properly. That is, how do we have to find mid of the linked list, then how do we have to reverse this linked list? Okay, so let's first discuss the first step of the solution, that how are we going to find the mid of the linked list. So what we will do is we will make use of 2 pointers, slow, which will initially point at the head of the linked list, and the fast pointer, which will also point at the head of the linked list. And we'll say that while this fast exists and the next of fast exists, correct? That is, the next of fast exists. Until then, what we will do, we will move the slow pointer by 1 step. And what does this mean? It means that we'll set slow as the next of slow. And we will move the fast pointer by 2 steps. What does it mean? It means that we set fast as the next, correct? So let's do it quickly, okay? So currently we'll check that is our fast null. So fast is not null. Is the next of fast null? It's not null. So what we'll do, we'll follow these 2 steps. So what we'll do, we'll move slow pointer by 1 step. So slow will point at 2. We'll move this fast pointer by 2 steps. So what we have set fast, we have set fast as the next. So fast will point at this 3, okay? Now we'll again check that fast null. No. Is the next of fast null? No. So what we'll do, we'll move slow pointer by 1 step. So slow will point at 3. And we'll move this fast pointer by 2 steps. So what we'll do, we'll set fast as the next, that is fast will point at 5. Now we'll again check, is fast null? No. Is the next of fast null? No. So what we'll do, we'll move this slow pointer by 1 step. So slow will now point at 4. And we'll move this fast pointer by 2 steps. So this fast will go at the next. So it means that this fast will point at 7. Now again we'll check, is this fast null? No. Is the next of fast null? No. So we'll move this slow. So slow will point at 5. Okay. And we'll move this fast pointer by 2 steps. So fast will go to its next. So it means that fast will point at this 9. Now again we'll check that is this fast null? No. Is the next of fast null? So what is the next of this 9? The next of this 9 is what? It's null, right? So what does it mean? It means that will not go inside this while loop. So what we can see is the moment we'll come outside this while loop, this slow pointer is pointing at the mid of the linked list, correct? So it means that we have got the mid of the linked list, and it means that we are done with the first step. And what we did in the first step, we moved the slow pointer by 1 step and fast pointer by 2 steps. And until when did we did it? We did it until the fast is not null, until fast exists and fast next exists, correct? Now, if any one of these 2 cases becomes true, then what does it mean? It means that we have got the mid. So what does it mean? It means that slow points at mid, correct? So it means that we are done by finding the mid of the linked list. Now what do we have to do? We have to simply reverse the linked list starting from this midpoint to the end point. Now let's see how are we going to do this. So this is the linked list from starting from the mid to the end. We can see that we have this 5, 6, 7, 8, 9, right? We have 5, 6, 7, 8, 9. Now what we want to reverse it. Now what does reversing means? Reversing means reversing this links. What does it mean? Let's see. So what do we have? We have 5, 6, 7, 8, 9. Correct. Now in the original list, we have a link from this 5 to 6. So in the new link list, that is in the reverse link list, what will happen? This link will get reversed. That is, we will have a link from this 6 to 5. Similarly, here we have a link from this 6 to 7. So this link will get reversed. That is, it will be now from this 7 to 6. Similarly, here it will be from 8 to 7 and it will be from 9 to 8. And this 9 will be the head of the reverse link list. Okay. So let's see how we can do it. So what we want to do is, here we can see that what is the next of this 5? The next of this 5 is null. So what we want to set is, we want to set the next of this 5 as null. Correct. Now the moment we set the next of this 5 as null, what will happen? This link will break and we will lose all this data. But we don't want to lose all these data. So what we will do is, we will store these data in a pointer called next pointer. Okay. And let's say that this current node, the node in which we are present, is represented by the pointer current. And since we want to store this null as well in somewhere, so let's store it as in previous. Okay. So what we did, we want to set the next of this 5 as null. So what is this 5? This 5 is nothing but current, right? So what we want to do, we want to set currents next as what? We want to set currents next as null. So where is null stored? Null is stored in previous, right? And what we did, we broke this link. So what we have 5 pointing at this null, correct? Now what we want to do is, we want to set the next of this 6 as this 5, correct? So what we will do, we will move all these 3 pointers by one step. So where will our previous? Our previous will now point at this current, okay? And our current will point at this next. And our next will now point at this 7, okay? So what we did, we moved all by one step. So what did we did? We set this previous as current. And we set this current as next. And what we did, we set this next as the next of next, correct? That only we did. Now what we want to create a link from this 6 to 5. So what we will do, we will set the next of this current as previous, because what we have in current? In current we have 6, right? So if we will set currents next as previous, we'll get a link over here and this link will break, correct? So now what we will do, now that we have created a link from 6 to 5, we will move all these 3 by one step. So our previous will now point at this 6, our current will point at this 7, and next will point at 8, okay? Now what we want a link from this 7 to 6, right? We want a link from 7 to 6. So what we will do, we will set currents next as previous. So where is current? Current is at 7. So we have set currents next as previous, means we have set 7s next as this 6. So this link will break. And once this link has been broken and we have set the next of this 7 as 6. So what we will do, we will move all these 3 pointers by one step. So our previous will now point at this 7. So we have previous over here and current will point at this 8. And this next will now point at this 9. Okay. So what we want now, we want a link from this 8 to 7. So how we will do it? We'll set the currents next as previous, right? So we'll set currents next as previous. This link will break. And what we'll do, we'll move all these 3 pointers by one step. So previous will now point at this 8. Current will now point at this 9. And next will point at null. Correct. So here is our next pointer. Now what we want to set, we want to create a link from this 9 to 8. Okay. We want a link from 9 to 8. So what we will do, we will again set the currents next as this previous. So we will get a link like this. And what we will do, we'll move all these 3 pointers by one step. So our previous will now point at 9. Our current will now point at null. And you can see that what we are doing over here, we are moving the next pointer as well. So we can see that the next pointer is null, right? So if we set, or if we try to access nulls next, then what it will give? It will give us a runtime error. Therefore, before setting this next as the next of next, what we have to do is we have to check that if this next exists, then only update this next as the next of next. Correct. Now we have successfully processed all the elements of linked list, because you can see that the current pointer is now at null, right? And we can see that this previous pointer is pointing at the head of the reverse linked list, right? So we'll simply return previous from here, indicating that we have successfully reversed this linked list. Now, once we are done with the second step, what we have to do, we simply have to follow the third step, in which what we are doing? We are doing reordering, right? And we already discussed that how are we going to do the reordering. So let's take another example and quickly do the dry run. So let's say if this is the linked list given to us, then what we have to do, we first have to find the mid. So how are we doing? We are taking a slow pointer over here and we are taking a fast pointer over here. So we can see that the fast is not null and the next of fast is not null. So what we'll do, we'll move this slow pointer by 1 step and we'll move this fast pointer by 2 steps. Again, we'll see that fast is not null and the next of fast is not null. So what we'll do, we'll move this slow pointer by 1 step and we'll move the fast pointer by 2 steps. Now we can see that the next of this fast is null, right? So what does it mean? It means that we have got the mid, and which is the mid? Mid is pointing at this 3 and we have it in the slope, right? So we have got the mid. So what we have to do, we have to follow the second step, which is what it is to reverse the linked list starting from mid to end, correct? That is, we have to reverse this part. So how are we going to do it? So what we discussed, this is for reversing the linked list. We have this at current over here. We have this over here as next, and we have previous, which is initially pointing at null. So what we have done, we have first set currents next as previous. So current is at 3. What we have said, we have set currents next as previous. So what will happen? This link will break, correct? Now, once we have set the next of this 3 as null, what we will do, we'll move all these 3 by 1 step. Our previous will now point at 3, our current will point at 4, and where will our next point? Our next will point at 5. Now, what we want a link from this 4 to 3, right? So what we'll do, we'll set currents next as previous. So current is at 4. If we set currents next as previous, we'll get this link and this link will break, correct? Now, once we have done this, what we'll do, we'll move all these 3 pointer by 1 step. So our previous will now point at 4, our current will now point at 5, and our next will now point at null, right? Now what we want a link from this 5 to 4, right? So what we'll do, we'll set currents next as this previous. So we'll get a link over here. And after that, what we'll do, we'll move this previous by 1 step. We'll move this current by 1 step. And we can see that next is already null, right? So we won't move this next, correct? Now we can see that this current has become null. It means that we have successfully reversed this part, right? And what is the reversed part? The reversed part is this 5, 4, 3. Okay. Now, once we have reversed this part, then what does it mean? It means that we are done with the second step and we have to follow the third step. So let's follow the third step. So what are we doing in the third step? In the third step, we are reordering this list, right? So how are we doing it? We are taking a pointer current. So where is this current? This current will initially point at this one, and we are having a pointer next, which will point at the next of this current. Then we are having another pointer, which is reverse head, that represent the head of the reverse linked list. So let me represent it as RH. And we are having another pointer and it's storing the reverse head next. Okay. So this is the next of the reverse head. Now what we want a link from this 1 to 5, right? Because what did we wanted? We wanted this 1. After that 1, we wanted this 5 in the new linked list, right? In the reorder list. So how will we do it? We will set the currents next as reverse head. So here is our current, here is our reverse head. So what we'll do, we will set the next of this 1 as 5. This link will break. Okay. Now once we have got this 1 and after this 1, we have this. Now what we want this 2, right? That is, we want this 2 in the next of this 5. So what we will do, we will set the next of reverse head as next, which we can see over here. What we did, we set reverse head next as next. So we will create a link from this 5 to 2, right? So what will happen? This link will break, correct? So let's remove these links. Okay, this get broken, this got broken. Okay. Now what we will do, we will move this current pointer by 2 steps. So this current was at 1. Now if it moves by 1 step, it will reach at 5. And if it moves by 2 steps, it will reach at this 2, correct? So we have current at 2. Okay. Now where this next will move? This next will now become the next of this current. That is, this next is now pointing at null. Okay. And where will this reverse head go? This reverse head will now point at the reverse head next. So it means that this 4 is now present in the reverse head. And where this reverse head next will go? It will move at the next of this reverse head. So what is the next of this reverse head? It's 3. So here would be our reverse head next, correct? Now what we want? We had this 1, we had this 5, we had this 2. Now we want 4, correct? So we want 4 over here, and after that we want 3. So what we want a link from this 2 to 4. So how are we going to get that? We will set the currents next as this reverse head, correct? So what will happen? We'll create a link from this 2 to 4, correct? Now what we want? After this 4, we want 3, right? But what we were doing? We were setting the reverse head next as next. But will we do that? We won't do that. Why? Because we can see that our next is null, right? Our next is null. So if we set the next of reverse head as next, then what it will have? We will have null after 4. But do we want that? We don't want that, right? We want 3 after 4, right? We can see that here we have 3 after 4. So we'll see that the moment this next will become null, we'll simply return from there. So what we have got? We have got 1, 5, 2, 4, 3, which is our answer. Okay. Now, I hope it is clear to you all, but if you still have any problem in finding mid of the linked list or in reversing the linked list, then I've created a separate video for these two, and I'll add it in the I button, or you can also check it out in the discussion, okay? So let's quickly code this. So what is the first step? The first step is to find the mid of the linked list. And how are we doing this? We are doing this by taking 2 pointers slow and fast, such that we are moving slow by 1 step and fast by 2 steps. until we don't have past as null or the next of past as null, correct? So let's create 2 pointers quickly. List node slow, and slow will initially point at the head of the linked list. Similarly, we will create a past pointer which will also point at the head of the linked list initially, correct? So what we will do, until this past is not null and then the next of past is not null, correct? So what we will do, we will move slow pointer by 1 step. So we will set slow as the next of slow, and after that what we'll do, we'll set past as the next, correct? Now, once we'll come out of this while loop, what does it mean? It means that we have successfully found the mid of the linked list. And what is the mid of the linked list? The mid of the linked list would be pointing at this flow, right? We can see here the mid was 3 and slow was pointing at this 3, right? Now, once we have found out the mid of the linked list, what do we want to do? We want to follow the second step. And what is the second step? The second step is to reverse from mid to end. And how do we reverse the linked list? We reverse this linked list by using the 3-pointer current, next, and previous, right? But before that, what we will do, we will set the next of this 2 as null. Okay. So for that, we'll create another pointer. Let's say it's called previous. And initially, let's say it's null. Now, what we will do over here, before changing this slow, what we'll do, we'll set this previous as slow. Now, the moment the slow will point at the mid of the linked list, this previous will be pointing just before mid of the linked list, correct? So what we will do is we will set the next of this previous as null, correct? So what we do over here, we follow the step 1, which was to find mid of linked list, right? Now what we want to do, we want to follow the second step, step 2. And what is this step 2? Step 2 is to reverse linked list from mid to end, correct? And where is our middle? Our middle is nothing but slow, right? So let me write slow over here, from slow to end, correct? So what we will do is we will write function reverse, which we will use to reverse the linked list. And what we will pass over here, we'll pass slow over here. So let us quickly write this function. Okay. So it will return us a list. So let's write list node over here, and the function is called reverse, and we'll get a list node. Let's name it as head. Now we will check that if this head is null, the next of the head is null. Okay, in that case, what we will do, in that case, we'll simply return head. Okay, now what does this mean? It means that if we have a linked list like this, or if we have a linked list like this in which there is only one node, then what would be the reverse of it? The reverse of it would be same only, right? Now what we have to do, we have to create 3 pointers, previous, which would be initially null. After that, we'll create another pointer, which would be current, which will point at the head of the linked list. After that, we need another pointer. Let's call it as next, which will point at the next of the head initial, correct? What we want to do, until our current is not null, right? What we want to do, we want to set currents next as previous, correct? Because what we were doing over here, we can clearly see that what we did, we set the next of this current as previous, right? And once we have done this, then what we were doing after setting this currents next to previous, we were simply moving all these 3 pointers, right, by 1 step. So once we have set currents next as previous, what we'll do, we'll set previous as current, we'll set current as next, and we'll set next as the next of next. But before setting next as the next of next, what we have to check? We have to check that this next should not be null, correct? Because if this next is null and we are accessing the next of null, in that case, what we'll get? We'll get a runtime error, right? Now, once we have come out of this while loop, then what does it mean? It means that we have successfully reversed the list, right? And what is the new head? The new head would be at previous. So we'll simply return previous from here. So what we have done, we have successfully reversed the linked list, and we are done with the second step. So from this, what we are getting a list node. So let's call that list node as reverse head, correct? Because that is the head of the reverse linked list. So we will call it as reverse head. Okay. Now what we want to do, we want to follow the step 3. Now what is the step 3? Step 3 is to reorder. Okay. Now for reordering, what we need pointers. What all pointers do we need? We need the current pointer, which would be pointing at the head of the linked list initially. We want reverse head, which is pointing at the head of the reversed linked list. Okay. And we want the next pointer and reverse head next as well. So what we'll take? We'll take list node current, which will initially point at the head of the linked list. Okay. Then we want another pointer as next, which will point at the heads next, correct? Now, we want one more pointer, which will point at the next of this reverse head. Okay. So let's call that pointer as reverse head next, correct? Because we'll be storing the next of reverse head in this. Okay. So let's say that it's initially null. Okay. Now we are going to set this reverse next only when this reverse head exists. If we don't have anything in this reverse head, let's say if this reverse head is null, then what will happen? Then we can't set the next of null, right? So we are going to set this reverse head next as the next of this reverse head only when this reverse head exists, correct? Now we have created all the required pointers. Now what we'll do, we'll say that while we have current, what we have to do, we have to set currents next as reverse head. Correct? We'll set currents next as reverse head. Okay. So what does it mean? Initially we had 1 which was in current pointer and this 9 was in reverse head pointer. So what we did, we set the next of this current as reverse head. Okay. And after that, what we want a link from this 9 to 2. So how we can get it? We can get it by setting the next of reverse head as this next pointer. Correct? What we were doing over here, we were setting the next of reverse head as next pointer, right? So we will simply say reverse head next as next. Correct? And what is this next? This next is the next of this current. But before this, we also have to check that this next should exist, right? If this next doesn't exist, then what we discussed that we are simply going to return. Correct? Now, once we have set the next of current as reverse head and the next of reverse head as next, then what we have to do? We have to move current pointer by 2 steps. So current will be the current's next. Correct? But before updating this current, we also need to make a check that this current's next should not be null. That is, we should have this current next, right? Because if this current next is null and we are trying to access null's next, in that case, we'll get a runtime error, right? Now, what we want to do, we want to set this next as the next of current, right? But before this, we also need to make a check that this current should not be null, right? Because if this current is null and we are accessing null's next, it will give us a runtime error, right? Now, what we will do, we will set reverse head as reverse head next, correct? And what would be reverse head next? Reverse head next would be the next of reverse head, correct? But before this, we also need to make a check that this should not be null. So we will check that if this exists, then only update this reverse head next, okay? And this while loop will run until we have current and until we have this reverse head, okay? Now, once this while loop is over, what does it mean? It means that we have successfully reordered the given list. Now, we also have to add check over here, that is if our heads next is null, okay, or our heads next is null. In that case, we'll simply return. That is, we won't do all these processing. Why? It's because if we have only 1 node in our linked list or if we have only 2 nodes in our linked list, right? Something like this. Then in that case, irrespective of whether we reorder it or don't, the answer will remain the same, correct? That is, if we have only 1 node, that is 1. Then if we'll reorder it, we'll get 1 only. And if we'll have 2 nodes, like 1, 2, then we'll get 1, 2 only as the result. So that's the reason why we added this check over here. Now let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Talking about the time complexity and space complexity. So if we have a total of n nodes present in our linked list, then the total time complexity would be order of n. Let's see how. So here in the first step, what we are doing, we are iterating over the entire linked list in order to find its mid, right? So it will cost us a time complexity of order of n. Okay. And what we did in the second step is we reversed the linked list starting from the middle to the end. Okay, that is, we traversed over the n by 2 elements of the linked list in order to reverse it. Now, time complexity for this would be order of n by 2, which would be order of n only. Okay. Now, what we did in the third step, we iterated over the entire linked list in order to reorder it. And it will cost us a time complexity of order of n. So, we will get order of n plus order of n plus order of n. That will give us order of 3n. So 3 is the constant, so we can ignore it. So we will get order of n eventually. And we are not using any extra space from our end, because of which the space complexity is order of 1. So that's all about today's daily LeetCode challenge. Thank you.